Okay, all right. Well, happy Friday. It's week 3 Friday. How are you guys doing? You guys midterms already? Did anyone ever already take a midterm or a midterm today?
Right after this.
Right after this class. Okay, well, good luck. Which class?
Math 115.
Oh, good luck. All right. Okay. So, yeah, popular times for a midterm is like week 4, week 7. Those are, really weeks 3 through 9, I guess, is midterm season. So, but yeah. Okay. Well, anyway, we are continuing on. So, I hope you guys. In my brain, I'm like, oh, I tell this. I'm hoping the students are reading their textbooks, but so I hope you guys are reading your textbook. So we have the Learn Python textbook, or Think Python textbook, and that covers base Python, which and it does a really good job of covering base Python. This lecture is going to cover NumPy. NumPy is not part of base Python, and so we're kind of departing from Think Python for a couple lectures. We're going to spend today talking about NumPy, and then next week we'll also continuing on here. I think it's NumPy, but I heard some people say Numpy, and I was like, oh, I don't know how I feel about that, but I don't know what, And then apparently you should always call it SQL and not SQL, but I feel like a lot of people say SQL, so I don't know. And GIF and GIF and whatever, Okay. So anyway, you need to, to use NumPy, you need to import it. So anytime you want to kind of use some module that's not part of base, so even like, and you saw this already, you had to import math, you had to import time and stuff like that. And normally you just do like import math, and then when you want to use math, you do like math.py or math.sine or whatever to kind of get at the functions within that module math. Here we're going to call import NumPy, and the convention is always to import NumPy as NP. So there's no rule, I guess the rule is not the right word, but if you import NumPy as, numeral pi or something, like, it's not going to break anything, but people will be like, what is wrong with this code, right? It just looks funny. So everybody calls import NumPy as NP, and that's what we have. And then now you don't have, if you do this, then you just do np.version, and this would be the same equivalent as doing NumPy version or something, and this will tell you what version of NumPy you have installed. And I guess on my machine I have 1.21.5, which is not the latest, I don't think, but it's probably good enough. All right, so what NumPy does is it creates a new data structure in Python called the array. And arrays are kind of like lists, but the key difference is that an array can only contain one data type. So in a list, you can mix integers and floats and strings and booleans and whatever else you wanted to put in a list, and that was fine. The array, NumPy array, is a lot like the vector in R. So you guys all are familiar with vectors in R, and if you had a vector of integers and you put in a type double, then it becomes, it coerces the entire vector into double and stuff like that. And NumPy arrays are kind of like that, in that everything within the array has to be a single data type, okay? And you create the array by using np.array, numpy.array, and inside that you can maybe you create a list, and then you put that inside numpy.array, and that's going to convert that thing into an array. So when you do that, it comes back and says, yep, we've got an array, and the contents of the array is 1, 2, 3, the elements 1, 2, and 3. When you, here I'm going to assign Numpy array, or assign the name A to this to the output here, and when you print out an array, it comes out with square brackets, and there's no commas in between them. So Python tries to inform you what type of data you have just in the way it's printed, right? So you always know you have an integer because there's no dots. You'll know you have floats if you see a dot, right? Even if it's like a whole number, if it's the floating point number 3, it'll be 3.0 or 3 point, versus the integer 3 is just 3. And if it's a list, you'll have square brackets and commas in between your elements. And if it's an array, you'll have square brackets with no commas in between your elements, okay? And if it's a tuple, you have parentheses and commas between elements. And if it's a dictionary, you have curly braces. And is there anything else? I don't know. Other kind of structures, Python tries to let you know what you're working with, which is a nice feature. Okay, and just to kind of contrast, the list will look like this. You've got commas in between the elements. An array, you don't, right? A printed array has no commas. The printed list does. And then when you ask, what is the type on this? It's going to come back and it's going to say it's an ND array, a numpy.nd array. That is the data type that we have. Okay, if you try mixing data types in an array, then the values of the most restricted type get upcast to the value of the less restricted type. So this is, in R we call this coercion, and in Python we call this upcasting. It's the same concept. We just have different words for it, but yeah, we call this upcasting in Python. So what is this going to, so we have the 1, the 2, integer 1, integer 2, floating point 3, Boolean false, Boolean true, okay? And so the 3.0 is a float, and it's going to upcast or coerce the other values to floats. And so we'll get 1.0 and 2.0. The false will become the 0.0, and the true will become 1.0, okay? Or maybe they just have dots, I don't remember. Okay, so yeah, 1 dot, 2 dot, 3 dot, 0 dot, and 1 dot, okay? And basically the same as 1.0. And here I put 3 in quotes, so that makes it a string, and so everything gets upcast to strings. So what are we going to get here? Quote 1, quote 2, quote 3, quote true, quote false, okay? And that's that, okay. You can have arrays in higher dimensions, so basically like a matrix. So matrix in R is basically a vector with dimensions attached to it, right? We learned this, right? So, and similarly, this is just an array with multiple, I guess it's technically what we have is, this is a 2x3 array. So this is interesting. It's the way you put it in Python or NumPy is that you kind of have it's an array of arrays. So here we're going to have, so this is going to be a 2-dimensional array, and one thing is you're going to have 2 opening square brackets. So you have an opening square bracket, and then you have kind of an array, 1, 2, 3, and then you have another array, 4, 5, 6, and then you have a closing square bracket. And this is going to create 2 rows, 3 columns, and it looks like this when you print it out. And you can tell this is a 2-dimensional array because you got kind of these 2 opening square brackets, and that tells you, this is how many dimensions you have. 2 dimensions, what you have, okay? If you try to create an array like this, what you will get is an array of lists, right? Which is not as useful. So you'll get an array where the first element is a list, 1, 2, 3, and the second element is a list, 4, 5, 6. Okay? So, and it says, you know what? We don't like to do that anymore. So this is actually, we get a list with 1, 2, 3 and a list 4, 5, and then it says this is deprecated, meaning so you get these kind of as packages get updated, they start throwing away old functionality, but they don't throw it away and blindside you. They usually give you warnings, and so they say, you know what, this is going to go away, and pretty soon this is going to start causing errors. Right now you're getting warnings. We're allowing it, but you better watch out. This is going to get and so it says, if you meant to do this, you have to specify a d-type object. So maybe I will update this. D-type equals object. All right, and then this will work, and it doesn't complain. But here, actually, let me do this. I'm gonna update our notes here. Okay, other ways we can make an array. So if you want to just establish an array of zeros, you can do numpy.zeros, and you give it 5, and there you go. Now you have an array of zeros. So in R, if you wanted like a vector of length 5, you would do like repeat 0 5 times or something, and that would work. By default, it's going to create, the zeros will be floats. And if you want integers, you can specify data type integers, and now you'll get an array of zeros. So here, there's a difference between just creating it and the output is this versus when you say print, right? So when you call print, there's technically the out is none, but the print comes out like this. But then if you just kind of specify the thing, the object it returns, it will come out into the array, and you'll have the commas there. Okay, you can also give it a tuple or a list or something that says, you know what, I want to make an array, and this inside here, rather than specifying just an integer of like length 5 or something, I give it a tuple of dimensions. And basically this says I want an array, 2 rows, 4 columns. And so now we get an array, 2 rows and 4 columns here, right? And if you want, you can create like a 3-dimensional array. So I'm doing 2, 3, 4. And so this will create a 3-dimensional array. And this will be 2, I guess, layers, 2 sheets. And each sheet has 3 rows and 4 columns. So we get like layer 1 and layer 2. I don't know what this would look like, right? So it looks kind of like, I don't know, some rectangle. Okay. And then what is 4 dimensions? So it's hard for us to picture 4 dimensions, but now I have basically 2 blocks. Each block is 3 by 4 by 5. Okay, 3 rows, 4 columns. 3 sheets, 4 columns, 4 rows, 5 columns. Sorry, I've got 2 entire blocks. Each block has 3 layers. Each layer has 4 rows and 5 columns. So, that's a lot of numbers. 120 values in here. And this is kind of how it appears, and it's arranged. And you can see how many dimensions it is. You have 4 opening square brackets, and here's kind of the first sheet, second sheet, third sheet, and this kind of encapsulates 1 block, and then here's the other block. Okay. In addition, you have to np.zeros, you have np.ones and np.full, which is pretty much exactly the same. np.ones, instead of zeros, you put in ones, and it works exactly the same. You can change the d type, you can put in multiple dimensions. And then here you can also call np.full, which is pretty much the same, but you specify whatever number you want to fill out the array with, right? So here I'm doing np full, 2 rows, 3 columns, and I want the number 1.2 to appear everywhere, or whatever number you want. If you don't want zeros, you can create random values, And so, so one thing you can do is you can specify a random seed so that your results can be reproducible on someone else's computer. So you would do np.random.seed. So pretty much everything that has random functionality is going to be found within np.random. Okay, so setting a seed is done by just doing random.seed, and you put the number in there, some arbitrary number, and then random.random. Okay, and this will give you kind of random uniform values between 0 and 1, and that's what we have. Most of these numbers have 10 to the minus 1, so this is 0.417, and this is 0.7203, etc., etc. This one's pretty small, 0.00011, and 0.3302, etc., etc. So here it says, give me 5 random values on the interval 0, 1. Okay. If you want random normal values, you have rand n for random normal, and if you don't specify anything, or rand n will come from the standard normal. So mean 0, standard deviation 1. So I run that, and we get negative 1.1 and negative 1.654, etc. Okay, they're all of them are negative. Oh, one's positive. Okay, 4 out of 5 are negative. I think that's reasonable. So that's that. If you want more, if you want something from a different normal distribution, not the standard normal, you can do random.normal, and you would do I want a mean of 10, standard deviation of 3, and I want the values in a 2x4 matrix. And there you go, mean of 10, standard deviation 3, and so we get that. Okay. You can also ask for random integers, and here basically you're kind of specifying a range, so from 0 to 10. And so this is basically this number over here is exclusive. It's a little bit weird, but you're basically saying going from 0 up to but not including 9, and I need 20 values. Right? And so this will give you a bunch of single-digit numbers. So if you wanted to simulate, say, like dice rolls, you can do this, and you'll get that, right? Random integers. And there's a whole bunch of random generators. So in the help, you can just go to Numpy. So again, I want you to get accustomed to reading the documentation, because the documentation you can always trust to be accurate and reliable, whereas answers on Stack Exchange often are very helpful and might give you the answer that you're looking for, but there's a problem, is that Stack Exchange answers from 5 years ago might no longer work with updates to packages and stuff, and they might be unnecessarily like your question might be like a simpler version of the question that somebody else asked, and they might bring in stuff that's actually not necessary, and you might be able to kind of think of your own thing with just by kind of looking at the documentation. So anyway, yeah, there's some good examples. Let me zoom in here on so you have random sample and all of this kind of stuff, and then where are all of the random generators? That's the random. Accessing the bit generator. Oh dear. Okay, so here are all of the different distributions that you can generate random numbers from, which, most of the time we probably use random uniform and random normal, but yeah, if you wanted to get values from the binomial or the chi-squared or the Dirichlet or the exponential or the f or the gamma or things like that, you have all of these different random generators here. What is legacy generator? Random state. Okay, yeah, that's not, we don't use that anymore. Okay, but anyway, documentation, useful to have. Let me give you your first view quiz answer. The letter E, E as in elephant. E as in elephant is your first view quiz answer for today. E, okay. All right, sequences. So you can do, so remember the range object. All right, so what will this do? Let's see if we remember how the range object in Python works. So if I do range 0, 10, 2, if I throw that into a list, what values will I see? 0, 2, 4, 6, 8. Yep, okay. Going up to but not including 10. And then, okay, so if you want to create a range in NumPy, you say numpy.arange, so make an array out of a range, okay? And you get basically the same thing, but now it's an array. You could also take the range object and put it inside the numpy.array function, and that's also fine, okay? So yeah, start, stop, step size, same functionality as the range object in Python, or not, yeah, in Python. So 0, 105 will start at 0, go up to 95, but not include 100 in there, right? So we'll go from 0, 5, 10 up to 95. Yeah.
So if you put like 101 instead, would it include 100?
It'll include 100. Yeah. So it's it'll include 100. Yeah. Yes.
Is there any reason that Python makes like this second number exclusive, or is that just kind of how it is?
Yeah. Yeah, that's just kind of how all the functions are, and so they're kind of, so that, I guess that's the convention, and so all of the things kind of follow that convention. It feels a little bit strange. I'm trying to think of like what advantage we have of that. I guess if you do like sequences of ranges, then you won't get overlap. It's kind of like in histograms. Usually when you have a bin, it starts on the left and goes up to, but the boundary on the right is exclusive. So it's a little bit like that. I don't know. So like if you did range 0, 10, range 10, 20, range 20, 30, you're not going to get any duplicate values. Like you're not going to get, so you can kind of go from 0 to, X to Y and Y to Z and so on and so forth, and you don't have to worry about Y showing up twice in your thing. I guess assuming the difference between X and Y is divisible by your step size. Okay. All right, and then you can also just say, oh, I want range 20, and that'll go from 0 through 19. So you have that. You have linear Lin Space, okay? And this this is like, oh, I hate Python, but no, we don't hate it. Okay. So Lin Space. So when you do Lin Space, this is going to be linearly spaced things. You're going to start at 0. You're going to stop at 100, and you're going to specify how many values you want. So this is going to start at 0, and it's going to go up to, and it's going to include 100. So Lin Space 0, 100 will go 0, 10, 20, 30, 80, 90, 100, and stop there. If I do Lin Space 0, 10, 10, what is the spacing between each of these things going to be? So it's going to have a length of 10. Okay, so we space it out 10, it's going to be 0, 11.11, 22.2, to so on and so forth until we get to 100. So this is like, it can be a little bit confusing. You can do endpoint equals false, and this will exclude the stop value. But now things get like wonky. So this will go 0 through 90, and And here I can do 0, 100, comma 9, endpoint false. So what will this do? So the last number here is 90. That kind of makes sense. What is the last number in this sequence going to be? The biggest number is going to be 88.88. So it's the same as doing whatever this was and just chopping off the last number. But you know, this in my opinion, using endpoint equals false gets confusing because now you don't know what the max value is. Like you have to like think about it, and you have to be like, okay, if I did Lin Space 11, you know, it would go 90, 10, and then I'm cutting off the last number, and so my biggest number here is 90. And this kind of makes sense, but then when you do this, you're like, oh yeah, I have, you know. So I don't know. To me, it's kind of hard to think about in terms of like, what is the largest number I'm going to get here? B, and it's basically you've done Lin Space with a larger number, and then you've thrown away the last number, which I would say just do it that way. So you don't have to kind of think about it. Okay, other things. So arrays have attributes. So if you have an array, you can ask the number of dimensions. Number of dimensions is basically like, is it a vector? I mean a one-dimensional array, which is basically kind of like a vector, or do we have a matrix? You know, with two things, right? So here I've got NP1s, 3, 4, 3 rows, 4 columns. So if I ask what is the dimensions, number of dimensions, it's going to say there's 2 dimensions here, okay? The shape is going to be this tuple, 3, 4, which is basically how many rows, how many columns we have. And the D type, what is the D type, data type that we have inside this array? D type is float, right? Because we have the dots, we see the dots, so we know it's going to be a float, okay? And the default is float 64. And technically, if you wanted to like save memory, if you're like, I don't know, if you're trying to save memory, Python's probably not the language you should be using in the first place. But if you really wanted to, you could say like, I want 32-bit floats or something, or I don't know, you have long floats. I think 80-bit floats if you want to, that will have more decimals, more places of precision and stuff. Did you guys talk about floating point arithmetic and stuff? Kind of? Huh? A little bit? I talk about it in 102A, but it's kind of like you know, with 64 bits, you have this many bits for the mantissa and this many bits for the exponent and stuff like that. Okay, but anyway. So anyway, that's the data type. Default for floats, float 64. You can specify other ones if you really wanted to. Okay, A range 0, 12, 1. What am I going to get? 0 through 11. Okay, number of dimensions here. I've got 1 dimension. And the shape is going to be, it's going to be length 12, and it's a tuple of length 1. Okay. Okay, we can reshape arrays. All right, so we can take an array that it currently exists, and we can give it a new shape, right? So you can also take the array and use dot reshape. Okay, so you can do numpy.reshape, give it an array and give it the new dimensions, or you can also just take the existing array and use the dot reshape method, right? And then there's also array.t, which will transpose the array, but leave the array unaffected. So here I'm going to create np.array arange, and this will just be some array j. This is one dimensional, so this is what we have, 0 through 11. And I'm going to say, let's reshape this. Okay, we're going to reshape this, and this will not affect j, but we're going to reshape it into a 3 rows, 4 columns. Okay, So one thing to note is that when you do this in Python versus R, Python reshapes it row-wise. So if you were to apply dimensions to a one-dimensional vector in R, if it reshapes it column-wise, and in Python it does it row-wise. Okay, so that's just one thing to note. Whereas here, if I ask what is J, J itself remains one-dimensional, 0 through 11 there. Okay, you can do the dot reshape method. Okay, and you can reshape it into 4,3, and this will create 4 rows, 3 columns. So very similar to this. And here, J also remains unchanged as well. So remember, we took the reshaped thing, K, which is 3 rows, 4 columns. I can transpose that, and we get the transpose. And if K itself is unchanged, K dot transpose doesn't change it. You know what? I'm sorry. Let me. Kids' elementary school's calling me, so give me a second. Okay. And all right, so you can take any of these things, and you can kind of do method chaining. So here, what's going to happen? I'm going to create an array. The result of this thing, I'm going to reshape. And then the results of the reshape, I'm going to transpose. Okay, so the result of this is going to be basically the array kind of filled out and vertically, right? So reshaped to 3 by 4, which gave me this, and then I'm going to transpose that to get that. All right, so we get that result there. Okay, once again, J, we start off with this one-dimensional array. Here, sometimes you'll see this in Numpy. You'll see this -1. And you're like, how can you have a dimension -1? Okay? What this basically says is, I want you to take the currently existing thing, and I want you to reshape it so it has 3 rows. And I can't be bothered to figure out how many columns it should have, right? So if you have some big structure, I don't know, 800,000 units or something, and you can say, you know what, I want the results to be a 3-dimensional array where we're going to have 100 rows, 20 columns, and I don't know, however many sheets or something. You can just put in a -1 into the last dimension. Okay, you can't have more than one -1, because then it's like, well, I don't know how you want me to reshape it. But you can just basically say, you know what, I want one of the dimensions to be 3. Please figure out how the other thing that you need. Okay, so it's going to say, oh, you want 3 rows. Okay, well then you're going to need 4 columns. And so Numpy will do the math for you to figure out what the appropriate thing is, right? You can also say, I don't know how many rows I want, but I do know I want 4 columns. Okay, and we can do that, right? Here, if you want to reshape it into, if you want to reshape it, it's like the Kool-Aid guy. If you want to reshape it into 2 sheets and 2 columns, unknown number of rows, you can just leave a -1. So you can leave a -1 wherever you want, just one of them, and you can do that. Okay. So that works. All right. What else? So this is often a little thing that you see. Why do you see like -1s and for dimensions and stuff in Python, and that's that. All right. Here's y again. What is the shape of y? It's a tuple with only one value in it, 12. Okay. If I transpose this, what am I going to get? It will be the exact same thing, okay? Because the transpose of a one-dimensional thing, so transpose really only makes sense if it's 2-dimensional, and Numpy does not see this as a 1 by 12, okay? It is just length 12. So transposing a one-dimensional thing doesn't affect it, right? It's not going to do anything. So if you wanted to like make a column of this, what you have to do is you have to take take the thing and you have to reshape it to be 1 by 12. Okay, so you can take y, you reshape it to be a 1 by 12. Now this is 1 by 12, okay? And now you can transpose this and you'll get a 12 by 1, right? So this is what transpose does. Now I can't remember what happens. Let me do j.reshape. Okay, so here's j.reshape. What happens if I try to transpose this? Okay. So j.reshape is 2 by 3 by 2. And if I transpose this, I need something. 2 by 3 by 4. How many is that? 2 times 3 times 4 is 24. All right, so let's do numpy arrange 24. 2 by 3 by 4. Okay, so we have we'll call this. So this is, I don't know. We'll do p. Did I do something wrong? Oh, okay. No. Dot reshape. I did. Okay. So here's p, 2 by 3 by 4. All right. What is p transpose? I'm not sure. I don't know how transposes work in higher dimensions. P dot shape is this. P dot transpose dot shape. 2 by 3 by 4. You get 4 by 3 by 2. What is P dot transpose dot transpose dot shape? Just 2 by 3 by 4. So you just swap the last two? I don't know. Okay. What does it mean to transpose a three-dimensional thing? Yeah.
So for like reshaping with -1, what if the number of elements isn't divisible by the?
Yeah, it's gonna. Here, let's see what we get. Okay, so let's say I do numpy dot arrange. We'll do 25, and then we'll reshape. So I can do 5 comma -1, and that's no problem, right? But what if I do 4 comma -1? And then it says, yeah, I can't do it. All right, so, but yeah. Okay. Oh man, we're gonna run out of time. Story of my life. Let me give you your last view quiz answers. What were they? Or the second? Oh shoot. Okay. I think it's okay. Second one is B, and the third one is A. Okay. Second one is B as in bear, and the third is A as in apple. Huh? B as in Bruin. B as in the best. And last one is A as an apple. Okay. NumPy. All right. So you can take arrays, you can subset them. This does exactly the same, and you can slice them. Okay. Slice them. Just slicing and subsetting works exactly the same as like lists. You can slice with a second colon as well. And this will, it's kind of like step sizes. So start, stop, and the step size. So if you do 1 through 8, colon 3, it'll pull out 1, 4, and 7. And so you can get all the even values by subsetting just to the even ones, or I mean, you could have just specified the even values by using arange this way as well. You can subset and slice higher dimensions using a comma to separate the subsetting instructions for each dimension. So here, I'm going to just reshape this into a 3x4 matrix or 3x4 array. And here, if I say, okay, I want 1, 2, what value is this going to do? It's going to go to row index 1, column index 2. It's going to pull out the 6. Okay, and the type on this is an integer. All right, here I can take z, right, and I can say subset to rows 0, 2, so it's going to take the first 2 rows and comma 0, 2, first 2 columns. So we're going to get this 2x2 corner, 0, 1, 4, 5. Okay, so the result of doing this is 0, 1, 4, 5. If you can also say I want row index 2, and then here you give it a blank colon, okay, blank colon blank, and that will take out the entire row, right? Extract the entire row. And for either of these things, if you ask for the shape, the row is going to be one-dimensional. Here I can say, what about the column? Okay, column index 2, all the rows. Okay, column index 2 will be 2, 6, 10. And this, the shape of this is also one-dimensional. So when you extract out basically one of the columns here, it's going to be one-dimensional there. When you slice a NumPy array, they are view objects. So this is kind of an interesting thing that if you aren't expecting it, it can be surprising. But they're view objects. So here, so here's my array. Here's Z. Okay, and I'm going to just take the first 2 rows and the first 2 columns, right? So that I could also just do :2, :2. I mean, I could do 0, 2, 0, 2, or I can just do :2, :2. This will just give me this 0, 1, 4, 5 top left corner, right? And what I can do is I can assign 99 to this top left element. Okay, so here I've got Z sub. I've sliced out Z to this top left corner. I'm going to modify this to be 99 up here. And so when I print, what is Z sub? Okay, Z sub now reflects that it's 99. So like in R, if we did this in R, this would like create a new object. And if we change something in the matrix Z, we wouldn't expect this new object to also change. But this is a view object, and so when we change this to 99, this also changes to 99, okay? So we can see, this is what 99 Z looks like. We change that top left element to 99, and then the thing is here, okay? This command here, I am creating an entirely, so sometimes we might get a little bit confused. This is not modifying, okay? This command does not modify Z. This is creating an entirely new array, and we're just reusing the name Z. So the name Z now points to this entirely new object. We're not modifying any of this thing, okay? So Z now looks like this, okay? Z sub still points to this array that we created long ago, and so it still looks at this thing, okay? So this object now still exists in memory. There's no name pointing to it directly, okay? But this object does exist in memory, and so Z sub still is pointing to this thing up here. If you want a copy that's not going to update, then you can slice it and use .copy, all right? So here, now I have this top corner, 0, 1, 5, 6, but this is a copy, and so if I modify that top left corner 0, 0 to 55, the copy is not going to get modified, whereas, I did modify that object up there, okay? If you have the view object, so remember the view object I've sliced to this top corner, 0, 1, 4, 5 here. I'm going to change the top left element of the view object to 99, okay? So the view object now has this, and the array is also modified, right? So the view object, again, it's like you're just looking at this part, and if you change it, you're actually changing the underlying thing, right? If you the view objects themselves have our Numpy arrays, and they have kind of the same attributes. So you can transpose them, you can reshape them, but yeah, the view object is still there. Okay. All right, that is it. I know I went through those last few pieces quickly, but they're there, and yeah, that covers view objects, which happens when you slice up an array. All right, have a great weekend. We'll see you all on Monday.